I want to talk about the values of the sine and cosine for some special triangles with some special angles. In particular, I want to talk about angles of 30 degrees, 60 degrees, and 45 degrees. For example, what is the sine of 30 degrees? Well, in order to demonstrate what that value is, I'm going to start by, by drawing an equilateral triangle. So here I'm making my attempt to draw an equilateral triangle. Now you know that the distinguishing characteristic of an equilateral triangle is all three sides have the same length. And it doesn't make any difference what that length is. I'm going to take the length of each of the sides to be 2. Okay, this could be 2 feet, 2 inches, 2 yards, 2 miles, 2 microns, 2 anything. Another distinguishing characteristic of an equilateral triangle is that all of these angles, all of them, are the same, and they're all equal to 60 degrees. So all those angles are 60 degrees, okay? Because the sum of the angles in a triangle must add up to 180 degrees. So what I'm going to do first is I'm going to drop the perpendicular, draw the angle bisector uh, from here. Let me do that differently. I'm going to draw the angle bisector from this angle down to the opposite line like this. So here's my angle bisector. And so this angle, if the angle bisector is done right, or the triangle is done right, this angle right here should equal this angle. And this line right here divides this angle in two. So if this angle is 60 degrees and it's divided in two, it makes each one of these smaller angles 30 degrees. Okay, so this one's 60, this one's 30, and we know that the sum of the three angles in a triangle must be 180 degrees. And this is 30, this is 60. They sum to 90. And the only way we can get all three angles to sum to 90 is if this is a right angle. So this angle must be a right angle. Now, and it's a right angle, and it also divides this side across here, going from here all the way over to here. It divides that side in half. So from here to here is now divided in half. So each one of these smaller sides is equal to 1. So this is equal to 1, and this side over here is equal to 1. So that's this dimension and this dimension are both equal to 1. So if you remember, the definition of the sine is that the sine of this angle, this is a right triangle, the sine of this angle is opposite side over hypotenuse. The hypotenuse here has length 2, and the opposite side has length 1. So we have then that the sine of 30 degrees is opposite side divided by hypotenuse, or 1 divided by 2. Okay, now, using that, we can also say, gee, what is the cosine of 30 degrees? Well, the cosine is adjacent side, that's this length, divided by hypotenuse. But let's figure out what this length happens to be. We can use Pythagorean theorem to tell us what this length is. The hypotenuse is 2, this side is 1, so we know that if this length of this side squared plus the length of this side squared must equal 2 squared. In other words, if we call this side h, we have to have that 1 squared plus h squared must equal 2 squared by Pythagorean theorem. Okay, 1 squared is 1. Okay, this is still h squared. And 2 squared is 4. So we have that h squared is equal to 4 minus 1, or that's equal to 3. So h is equal to the square root of 3. By, we get that taking the square root of both sides. If h squared is equal to 3, h is equal to the square root of 3. So now we have the length of h, and we can compute the cosine of 30 degrees as being h divided by 2. So we have cosine of 30 degrees is equal to h divided by 2, or square root of 3 over 2. Okay, so we now have that the sine of 30 degrees is a half, and the cosine of 30 degrees is the square root of 3 over 2. And let's look at 45 degrees. And what do we get when we compute the sine and cosine of 45 degrees? Okay, let's look at this angle. Let me just eliminate that. Don't save. Okay, so here's what we have. Let me draw a triangle, an isosceles right triangle. Okay, so here's an isosceles right triangle. We'll make that and this should be about the same length. Okay. So let's say this is 1, this is side 1, this angle here is 45 degrees. This angle here is 45 degrees. And this angle here is 90 degrees. Okay, now again by the Pythagorean theorem, if we want to compute this hypotenuse, let's call this r as the hypotenuse, we know that r squared is equal to 1 squared plus 1 squared. So Pythagorean theorem tells us that r squared equals 1 squared plus 1 squared. And that is equal to 2. So r squared equals 2 means that r is equal to the square root of 2. Okay, so r is equal to the square root of 2 right here. This is equal to the square root of 2. So the sine of 45 degrees is opposite length, which is 1, divided by hypotenuse, which is the square root of 2. So sine of 45 degrees is equal to opposite, which is 1, divided by hypotenuse, which is square root of 2. And we get exactly the same result for the cosine of 45 degrees, because the cosine of 45 degrees is adjacent divided by hypotenuse, which is also 1 divided by the square root of 2. So cosine of 45 degrees (1 divided by square root of 2). Okay, so those are sines and cosines for some of our special angles, in particular 30 degrees, 40 degrees, now 60 degrees. The final angle I want to look at here is 60 degrees. And I'll tell you what the result is. It's because 60 degrees and 30 degrees are the opposite angles in a 30, 60, 90 triangle. So it looks something like this. So if this angle right in here is 30 degrees, 30, this angle right in here is 60 degrees, this angle is 90, what we have is that the sine of 30 degrees equals cosine of 60 degrees, and that equals a half, okay, just from before. And similarly, we get that the sine of 60 degrees is equal to the cosine of 30 degrees. Now, how do we compute again what that was? Okay, we said, remember we had this side was 2 and this side was 1. We computed this side as h as being h is the square root of 4, which is 2 squared, minus 1, which is 1 squared. So h is equal to the square root of 3. And that makes so this side is the square root of 3. So it makes this cosine of 30 degrees equal to the square root of 3 divided by 2. Okay, so there we go.